We're going to see how to download OpenBDLM on your computer and make sure your MATLAB is set up correctly so you're able to use it. So first step, you go on GitHub and you either clone it through GitHub or you download the OpenBDLM package through a zip folder on your computer. So once you make sure that it's downloaded correctly, you can find it somewhere on your computer. It's time to tell MATLAB where are these packages. So you're going to go in set path, and if you have some folder already defined here, I recommend you to set the path to the default MATLAB path. You're sure you're not going to have any mistakes. So first step, what you're going to do is add with subfolders, and you're going to say to your computer, where is OpenBDLM? So here it's here, and open. So it's going to find all the folder along with all the subfolder that are defined in OpenBDLM. When it's done, save, and you can close. This might take a couple of seconds. When it's done, second step, tell MATLAB where you want to work. So for this, you need to set, okay, where is that folder OpenBDLM on my computer? So first thing you can do, you can type OpenBDLM main. So this is the main file to start OpenBDLM, and the semicolon is to suppress the potential output from the function. So if you do this, this is the main interface you're going to see. So right now there's no file that are preloaded, so you don't see much. So you can either use the interactive tool by typing 0 to load new data. This is what we're going to see in the next tutorial. So for now, there's not much we can do. We're just going to do Q for quit. So the first thing we can do is that there's a preloaded demonstration in OpenBDLM, and we're going to run it. So if we type run underscore demo capital letter, semicolon again, we type return, and we're going to see that everything is running in batch mode through OpenBDLM. So first thing we can see here is from the data we loaded, this is the data availability. So from 2001 January till 2005 January, we can see that the green line indicates what is the data availability for time series number 1. So in this demo, we have only one time series. The second thing we can see is here, what is the time step length in our time series. So here the reference time step is 24 hours. This is what is indicated here in log scale. Perfect. So this is what our data look like. So what you can see here is going to be the amplitude of the time series you have. So the amplitude of the time series you have, can see that you have a periodic effect as well as an accelerating trend that is underlying that reversible effect. And here you can see in that time series we have no missing data. So in my case here, it asks me, do you want to overwrite the data that was already preloaded? In your case, that might not be a question. Here, I say, yes, I want to do it. So I want to override again. Now it's going to calculate all the hidden states. So now OpenBDLM has run, and from the raw time series, it separated it into many hidden components. For instance, here we have an autoregressive component that represent the residual, what the model cannot explain. So if we zoom in, we're going to see we have two superposed trends. So the red line is the ground truth, because in this demonstration, this is simply simulated data. So we can compare the performance of OpenBDLM with reference benchmarks. So here we can see that our hidden state estimation, represented by the black line as well as the green confidence interval, is really well approximating the underlying truth. So we can see here we have our 5 years of data. This was for the autoregressive component. If we look at the reversible effect, represented here by the periodic component, here we have two hidden states. The number 2, we don't care about it. We only care about the first one we can see here. So this represents the amplitude of the reversible sine-like effect that's present in our data. Then we can have what is the acceleration we could see on our raw data. This is our estimation for the acceleration. We see that our estimation matched pretty well the ground truth. We have here the speed. So this is the speed that has a constant trend for our case. And this is the the baseline of the structure, so the underlying downward accelerating trend that we have. And this is again the plot of my raw data that I'm predicting with OpenBDLM. So this is all to see how OpenBDLM run correctly on your computer and can take a simulated time series and analyze it. So once you will have run this configuration file, there would have been a config file that would have been created on your computer. So if you go in config file, you're going to see that CFG demo has been created on your computer. So if we open it, we're going to see that we have the project name, we have how data is loaded, we have the model configuration, model parameters, initial value for your hidden states, and many options that you can manually tune for different analysis you might want to do in OpenBDLM. In addition to that, if you go back in OpenBDLM, you're going to see that now we have one file that is preloaded. That one file is the same we just obtained with run demo. So if I do one, I have access to a menu where I can redo many of the steps that were already done. For instance, if I want to plot back the hidden states, I can go 3, 1 for filtering, and OpenBDLM is going to re-estimate the hidden states and plot them again for me. So you can see this is the autoregressive pattern, the periodic we add, this is the acceleration trend representing the speed and local level, and the predicted time series from the superposition of all hidden components.